Hello everyone, I'm going to show you another example in HYSYS, which is a two-phase flash drum with the Peng Robinson vapor-liquid equilibrium correlation. In this example, the feed is 45% normal butane and 55% normal hexane, which are at 1 atm. The feed is completely saturated liquid. It means that the vapor fraction is equal to 0. The drum pressure is 0.8 atm, and we are going to do the simulation for vapor to feed ratio equal to 0.2. In order to start the simulation, in the File tab, we are going to click on New and select a new case. So, as you can see, we have to enter our components and also select our fluid package. As I mentioned before, for adding our components, we go to the component folder and just click Add. And we can search the components by name or chemical formulation. We have normal butane in the system and also normal hexane. So by just searching and click enter or using this add button, you can add your components to your list. And as you can see, I have two components in my system showing here. The next step is to select the fluid package. You can find the complete information for selecting the fluid package in the PowerPoint I have uploaded to Canvas. So just click add. And for this problem, we are going to select Peng Robinson as our property package. And as I mentioned in the previous video, you have to check this bar, and now it's green and okay. That means that we have chosen the correct fluid package for the system. So let's click on the simulation tab and enter the simulation environment. The first thing that we have to do is to add a material stream, which is our feed stream. So use this blue arrow and click on it and add it to the simulation environment. So we are going to input the given information in the problem statement and complete the information about our feed stream. So let's just first change the name for this stream. I'll call it feed. And then, as I mentioned before, it's completely saturated liquid, so vapor phase fraction is 0. And I mentioned before that the feed is at 1 atm. And as I mentioned before, by entering number, you can choose the correct unit. And the other thing is that the flow rate is 1 molar flow rate is 1 kilomole per hour. And also we know the composition, so from condition switch to composition window. It was mentioned that 45% of the feed is normal butane, so 0.45 and 55% is normal hexane. So just click OK after entering the compositions, and you can see that this bar went green, so it means that we have enough information for our feed stream. So just close this material stream for the feed stream window, and then we are going to add a separator. As I mentioned before, you can use this model palette, go to the separator tab, and choose the first vessel, which is a simple separator, add it to the simulation environment, and just double click on that. So in the separator window, we are going to work in the design tab as the first step. We are going to introduce our inlets and outlets for the separators. So we had a feed stream, and also choose a name for our vapor outlet. I chose V and L for the liquid outlet. Also in this example, we are going to add energy stream for the separators. So you see that we are currently good, but when I add the energy stream, the problem is that the system is asking for the duty. So instead of entering the duty, we are going to parameters, and it was mentioned in the problem statement that the drum pressure is 0.8 atm. So the drum pressure is equal to the vapor outlet pressure of the stream of the separator. So just 0.8, and the unit is atm. So just close this window and click run again. Oh, sorry, one more thing we had to do is again double click on the separator. And another given information in the problem statement was that the vapor to feed ratio is equal to 0.2. So where can I add this information? In the window for the separator, just switch to worksheet tab. And we have to consider this ratio. So if my feed molar flow rate is equal to 1, so my vapor molar flow rate should be 0.2 with respect to the value for my feed stream. So in this case, I put 0.2 for the vapor outlet. So the ratio of V over F will be equal to 0.2. So you can see after entering this given information, we will have no problem regarding the unknown duty, and this separating process has been solved in HYSYS. So again, in the worksheet tab, you can check the results, the temperature for each stream, the pressure, and also the value for the heat, required heat to reach this final composition. So switch to the composition tab and check the final compositions for liquid and vapor stream with the given information in the problem statement. So in this problem, you also learned how to add DUT for our separator, which we did it in the design tab, and instead of giving the amount of heat that we need to do this separation, we just provided the pressure for the outlet vapor, and by providing the pressure for the vapor outlet and also the ratio of these two streams, we calculated the Q and the compositions at the outlet. Hope this video has helped you to learn how to run a separator in HYSYS and considering a duty for your vessel. Thank you, and let me know if you have any questions.